Once all these procedures have been completed, the test can begin. Using the computerized controls, the test engineer remotely ignites the furnace burners. When the temperature inside the furnace reaches a predetermined temperature, the clock will start and the test period commences. The temperature inside the furnace is also measured using thermocouples, again arranged to a set distribution, and displayed on the computer screens in the control room. A separate computer is available for the client to monitor the test, either from the control room or, if test conditions permit, from the floor of the laboratory. Although on Chiltern International Fire's furnace, the computer automatically controls the furnace to follow the test standard, the senior test engineer will still carefully monitor what is happening. Using his testing experience, the information he receives may help him anticipate what is likely to happen. While the senior engineer carefully monitors what is happening, test engineers equipped with breathing apparatus and radio links to the control room record observations of the specimen and take regular distortion measurements. Temperatures inside the furnace are high, reaching 800 degrees Celsius after 23 minutes, and almost 850 degrees by the end of a half-hour test. By the end of a 1-hour test, temperatures reach almost 1000 degrees Celsius. However, it is not only the temperature which must be monitored. Using dampers in the furnace flues, the pressure is also controlled to follow the requirements of the relevant test standard. To give a representation of conditions in a real fire, the standards specify that the furnace pressure must be positive towards the top of the furnace, pushing flames and hot gases through any gaps in the specimen, but negative towards the bottom of the furnace, drawing air into the furnace through any gaps in the specimen. At a set distance above the threshold, a neutral point is specified, where the furnace pressure is the same as the laboratory pressure. Both negative and positive pressures can contribute to the failure of a test specimen. It is in the type of thermocouple which measures the furnace temperature and in the specified pressure regime that the British and European tests primarily differ. The British BS standard specifies 1.5 mm probe thermocouples, whereas the European BS-EN standard specifies plate thermocouples. For the BS test, the neutral pressure point is set at 1000 mm above the threshold, whereas for the BS-EN test, the neutral pressure point is set at 500 mm. Both these differences can have significant effects on the performance of specimens, generally making the European test more challenging. For most fire performance tests, the key piece of data is the time to integrity failure, though for some products, the time to insulation failure will also be important, particularly for glazed specimens and for European tests. In a few tests, the radiation performance may also be significant. The test specimen is deemed to have failed the integrity criteria when one of the following occurs. A cotton wool pad applied over any gaps or glows on the specimen subsequently ignites. There is continuous flaming for more than 10 seconds. Either of two types of gap gauge can penetrate fissures or gaps in the specimen. As well as recording the time to integrity failure, the time to insulation failure can be found from the thermocouple temperature readings on the unexposed face of the specimen. Initial integrity failure is not always the end of the test. Where possible, the failure will be dealt with and the test will continue to discover other later failure points. This may be very useful in later assessments of the test data, or may help identify weaknesses which need addressing prior to a retest.